the fourth important theorem, okay, of algebra of partial derivatives. See, this theorem says derivative of f into g is equal to f into derivative of g plus g into derivative of f. It is same as in 12th standard we have studied this formula, derivative of u into v. This is nothing but u into derivative of v plus v into derivative of u. We call it as u into v formula of derivative. Getting so same formula we get for partial derivatives also. So this result we have to prove. We will start with given information. What we have? We have the thing we have, that is these two partial derivatives exist. Deva f by deva xi of a and deva g by deva xi of a exist for I is equal to 1 to n. So both derivative exist, so we can apply definition and write by definition. By definition, what will get? Deva f by deva xi of a, you know the definition, limit h tends to 0. We are taking derivative with respect to xi, so that's why I will add h only in ith component. F of a1, a2 and so on, ai plus h and so on n minus f of a1, a2 and so on n divided by h. Similarly, I can write for deva g by deva xi also of a is equal to limit h tends to 0. Same definition I write for g of a1, a and so on, ai plus h, comma and so on n minus g of a1, a2 and so on n divided by h. We are taking derivative, we are taking derivative with respect to xi. So that's why I am adding h only in ith component. I will call it as equation number 1 and this as 2. After that, we will go for the actual proof of this theorem. You can make a screenshot of it. After that, we will continue. So let us start with left hand side. Let us follow the definition. Limit h tends to 0. F into g is there. So I suppose to write f into g of a1, a2 and so on, ai plus h and so on n. We are taking derivative with respect to xi. So that's why I am adding h only in ith component minus f into g of a1, a2 and so on n divided by h. Okay, so this is equal to limit h tends to 0, f into g of this bracket, that means f of that bracket into g of that bracket. So therefore f of a1, a2 and so on, ai plus h and so on n into, now g will operate, there will be a multiplication between them, g of a1, a2 and so on, ai plus h and so on n minus. Same thing will happen here, getting f of that bracket into g of that bracket. So f of a1, a2 and so on n into g of a1, a2 and so on n whole divided by h. See, now I'm going to add a few terms. Without that we cannot prove it. Okay, see what I'm going to do. Limit h tends to 0. First of all, I will copy it first. F of a1 and so on, ai plus h and so on n into g of a1 and so on, ai plus h and so on n minus. Okay, now I'm going to subtract f of a1 and so on, ai plus h and so on n into g of a1, a2 and so on n. See, I have adjusted this term. Okay, so I have subtracted, so I should add it here. Plus f of a1 and so on, ai plus h and so on n g of a1, a2 and so on n. So same term I subtracted, I added. After that, I should continue the last term minus f of a1, a2 and so on n into g of a1, a2 and so on n whole divided by h. Okay, this is equal to limit h tends to 0. Will you tell me what can we take common from numerator? From first two terms, we can take this f of a1, a2 and so on, ai plus h n. First term you can take common, okay. So therefore, f of a1, a2 and so on, ai plus h into and so on n. I am taking common. So that means we will have this g of this bracket minus g of that bracket. So therefore, g of a1, a2 and so on, ai plus h and so on n minus g of a1, a2 and so on n. From next two terms, can you tell me what can we take common? From next two terms, we can take g of a1, a2 and so on n common. So g of a1, a2 and so on n. If you take this second term common, we will have f of a1, a2 and so on, ai plus h and so on n minus f of a1, a2 and so on n whole divided by h. You can make a screenshot of it. After that we will continue. So let us continue. What will I do? I will divide separately by h. Okay, first term by h plus second term by h, and I will apply separate limits. See what will happen is equal to limit h tends to 0 f of a1 and so on, ai plus h and so on n. In bracket we will have g of a1 and so on, ai plus h and so on n minus g of a1, a2 and so on n whole divided by h plus, okay, as I told you earlier, I am going to apply separate limits. So I will apply limit to this term also and divide by h. So limit h tends to 0 g of, see g of a1, a2 and so on n, this is nothing but a. So a f of a1, a2 and so on, ai plus h and so on n minus f of a1, a2 and so on n divided by h. Let me remove this part, it is not required now, we have used it here. Okay, see what will I do after this? I will apply here also again separate limit. So this is equal to, if I apply separate limit, so what will I have? If I put h is equal to 0 here, ai plus 0, we will have ai. That means f of a1, a2 and so on, ai and so on n into limit h tends to 0 here, what will I get? G of a1, a2 and so on, ai plus h and so on n minus g of a1, a2 and so on n divided by h. What will I do here? G of a is a constant, it will come outside the limit. So plus g of a, so I am applying limit to that bracket only, limit h tends to 0 f of a1, a2 and so on, ai plus h and so on n minus f of a1, a2 and so on n divided by h. So this is equal to, this is nothing but f, getting h is not there, so this is nothing but a. So if I consider, if you remember equation number 2, so this is nothing but dA by g by dA by xi. So dA by g by dA by xi of a plus we have a g of a, and if you remember the equation number 1, this is nothing but dA by f by dA by xi. So this is dA by f by dA by xi of a. So I need to mention from 1 and 2. So you remember we started with what? I have not written here. So therefore we started with f into g of a, and we proved f of f into derivative of g plus g into derivative of f. In this way we have proved, and this is true for all I running from 1 to n. So in this way we have completed the proof of this result also. You can make a screenshot of it, and after that we will stop. Thank you. Bye bye.